Hello, my dear brothers and sisters. Thanks for joining today. First of all, many apologies to all of you because I couldn't do it last week and also wanted to do it once I have some free time. So today, I am happy that I can bring this to you. And finally, I have certain spare time in my hand and just wanted to get over with this business. So, well, before we start our today's tutorial, first of all, many thanks to all of you again for showing your interest in learning R programming because irrespective of the field where you are from, I think learning R programmings are really essential because whether you are a biologist or a physicist or an economist, the one of the fundamental concepts in any field of science is to analyze your data set and make a very good visualization out of it, right? So in that perspective, R offers something really amazing. And I'm gonna convince you how exactly it works and why is it even better, I would say, in some certain available tools that are available in the markets which can be which can has to be subscribed, for instance, like they are not for free. On the other hand, the R is completely free and it's an open source tool. Without doing a further ado, I would quickly hop over my PowerPoint presentation and well, so before I begin today's presentation and also the discussion and the demonstration afterwards, I would like to say that I'm doing it as a part of Kiel University's Science Communication Certificate program. So in Kiel University, we strongly believe that science education are not really limited to the scientists. Anyways, we also have certain responsibilities to the societies. For instance, if you are a person who is actually researching on something, it's your responsibility to actually, give a talk or try to explain your research to commoners to make others understand why are we doing and why is it important. So I have decided to do something with the data analyzation and statistics because I think it can be very crucial for some of you. And also I would like to show how we analyze our data set for our research. That kind of sort of a motivation for you, maybe for your for future research work. And you can also use that in your study as well. So at the same time, I'm gonna help you in your research. At the same time, I'm going to teach you something really new, or maybe that some of you already know, would like to brush up your skills on. Well, as I already said, why are we using R? Because it's open source, meaning that you can actually download it, install it, use it, and of course you have to cite it at the end. It's a statistical tool that would also come up with a fantastic visualization at the end. So like you can either use this as a statistical computing system, or you can also use it to create your box plots for the data that you have generated recently. So at the same time, it offers you fantastic statistics and also great data sets with a visualization. Also, it can be even simpler and we can also increase the layer of complexity. It can also handle a large data set, for instance. Well, while I show you a demonstration, maybe I would try to convince you how is that and exactly how exactly can you use RStudio or R packages to do your day-to-day research analysis job. It has got a strong community support. I must say, R is one of the most fundamental programming language in today's world, especially for the researchers, and it has got a strong community support. You face any difficulties with any of the packages, you face any bugs, of course, there are 1,000 people around you, and you can just directly ask them in the Slack, and they are going to help you with the possible answers or maybe the possible troubleshooting options. R has got a numerous useful packages and the developers are developing day by day to help us actually to help researchers to be very honest because like it's not our job to develop package. Let's be very honest about it because we as a scientist or as a researcher, we use those package to analyze our data. It's since I'm not a bioinformatician or a computational scientist, I would not really develop something by myself. Rather, I would use the package that has been already developed and described and well documented. I hope it makes sense to you as well. Now, where to find R? Well, you would get this in CRAN mirrors. Now, what does CRAN even say? It's comprehensive R archive network. So it's available on the internet. You just have to do what you have to do is like you have to go hop over the website and get it downloaded in your system. Like any other tools or any other softwares, you get to install this in your system and you are good to use with them. The second thing that is important for R programming is called RStudio. It's integrated developmental environment. Like any other programming language, we also use RStudio to do the programming work for R. Now, I would quickly hop over to the websites and try to convince you by showing how exactly you can download RStudio and R. For that, I have to change my screen to this. I hope you can see, still follow my screen. And from here, I would just type CRN mirrors. Once you go there, you just click on the first option. You would see a huge list that are the available mirrors. Now, what are these mirrors actually? So these are the local repository based on your location, and you can download them in your local computer once you need them. For instance, since I'm in Germany now, I would hop over to this particular area and I can choose just any of the mirrors. For example, the one is offered by Dogado GmbH or University of Munster in Germany. It doesn't really matter. You just have to select anyone. Maybe I will click for the Munster, and that will take me to a page. And of course, you have to select your distribution. For instance, are you a Windows person or you are using Linux or Mac? Any of the operating system you have to choose. Since I'm a Windows person, I will choose this option and then you have to install. Now, I will not go over this option because I have already installed in my system. So I hope you can also do it by first of all, like selecting your distribution and then just install it to your PC. And once you have done it, the next thing what I'm going to show you is RStudio. So you can also download RStudio. We will go over to this particular link and then install RStudio for Windows. It is important to say if you are a Mac person, you can still use R programming. You can also use R programming if you have been using a Linux distribution. But for the R tutorial especially, I would restrict myself with the Windows system as well. Because if I go for the Python data analysis tutorial and also if I do something on Bash, I would rather choose Linux in that case. So many apologies for those who have been using Mac and Linux for now. But I hope the principles and the programming itself are very similar, irrespective of the operating system that you have been using. Like any other softwares or tools, as I already said, you have to install it in your computer that you are already familiar with, I guess. So assuming that you install these two particular softwares in your computer, now I would show you a little bit of demonstration in RStudio. For that, I would directly jump over to my R environment, which is here. And yeah, then let's start working with our first R script. So this is something called as RStudio that I already said. I also asked you to install this. Why is it better and why is it more user-friendly? Because it has got a lot of interactive features, for instance. So I hope you can follow my mouse cursor. Yes, you can. Yeah. So here what you can see actually, the first tab is called text editor or the script editor, where you can actually type in your script or the program that you want to run, and you can save it or share it with others. On the bottom of this particular tab, we have got the console. So it is basically the command prompt that is running in background. On the upper right-hand side, you have got the environment history, and you can also expect some tutorial for some of the packages, some of the functions that you are not well versed of. And whatever you would do in your console, running via your script editor, it's all getting loaded to your environment. Now, it's all very abstract because I haven't really run any operation, but once I would start, you can actually follow that. And regarding the last tab you have on the on the right hand side bottom, it's called the plot packages and files. So you can basically navigate your files. You can upload that to your R environment and do your analysis, for instance. It's important to say R can be extremely simpler. You can actually use it as a basic calculator. For example, here I have written one variable called a, and then I assigned 2 plus 1. That's a mathematical function, you could say. That's a simple math. And I asked it to carry the result within that variable. And I would just now try to display that in the console. So let's just do it. For instance, if you write a from your keyboard, give a space, less than symbol, minus 2 plus 1. And then I think if you press enter, once you are on your script, it actually changes the line. So what you have to do for that, you have to press Control or Command if you are a Mac user, and then you hit enter. Have you seen what happened immediately? So what did it do? It basically assigned the value 3 under this variable. Now once you say, let's print A, that will print the result 3 in your console. So it is also important to say, if you are not really familiar of using this particular arrow, you can also do it like equals to. At the end, it's the same. If I say A equals to 2 plus 1, it's again assigning this particular thing. I think you can also follow in the console that whatever task I am doing in the script, it's automatically getting uploaded here and the results are here. And then once you type A again, you have this value 3. So you have two alternatives. You can either use equals to, or you can use arrow, and then you can assign some values there. Okay, as I said, step by step, we can also increase the layer of complexity. So let's try some other examples. For instance, I am assigning a variable called m, which can be slope. I am also assigning something y-intercept called c, it's -3. And then I want to generate certain x values that are the independent variable with a sequence from -10 to 10. Like you have 0 here, -10 to 10, with a gap between 0.5 in each. So I think now you already know my plan, because I want to actually help you to visualize a straight line equation. So most of you know, how does a straight line look like? It's basically y equals to mx plus c. So I have also written the equation here. It's y equals to mx plus c. You load it, and then you can simply plot it. How easy it is, isn't it? You can just say plot and x comma y. I think it's extremely important that you also just remember, but also, you know what? You don't have to actually remember. I can also show it to you. If you just write plot, automatically it allows you to come with 2 parentheses, and within this parenthesis, you can write x, comma, y, comma. Now I'm going to explain you what does it mean by type. So type is L, means line. So the plot at the end would expect to show you some line. That is the reason why it calls line. Now the color of that line would be red. Now if you don't like red, we can change it to blue. And that is the good part about R. You can actually customize it. You can actually make it entirely yours. You can modify it in every single level. And I'm pretty sure you can't really do that in any third-party tools. I don't want to name it here, but you already know. If you are familiar with any third-party tools, there are a couple of examples, and they also give you very good visualizations. But at the same time, I think they are not really that easily can be manipulated, right? And also important thing in today's scenario is that once you do any analysis, I think you know this already, you're supposed to submit your analysis results, the raw files, to the journal. Now, if you use any third-party tools, you are expecting or you're assuming that the person who is going to be the reviewer for your research article, they have access towards that particular tool. But it may not be the case, for instance. They may not have the access to the tools that you have used. But if you use something like R that offers an open source information, meaning that the person can also use it, the script that you develop, he or she will run the exact script that you developed, and then they will get the answer that you have got. So at the same time, it can be easily shareable with others and very, very transparent. And that is the beauty of R. Like you do your analysis, you share with others, they can also modify. Just with a click of a button, they can also generate the plot that you have actually got in your results, right? So as I said, color is now blue. LWD is line width. So how thick you want to see the line. LTY is line type. It's 1. Now I will come back to this a little bit later because I have to show you something also really interesting. And the main is like what will be written on the top, like the title of the plot. And then X label is X. I don't really change anything here. You can also write something like X label is maybe X lab and Y label is Y lab. Now you can write anything here because this is how they will show the X axis. Now I hope yes, I have completed up to this step. So as you could see, we have a straight line equation. And the way we instructed, it actually followed every single step. And now you have a blue line with a width of 5 and a line type 1. Let's go back to the line type. What does it say? If you say line type 2, let's see what it does. So you have a dashed line, for instance. Now you can try this with multiple options. For example, line type 3, I think the distance between the gaps are also getting closer and the line type is also getting changed. So I think you can also study this from the internet. What are the different line type options you have? You can change the color and you can plot any values or any plots you want to plot. And what you have to do, you have to modify your slope, y-intercept. You can also change, you can also give certain x values, and then you have your plot ready. Let's increase our level of complexity a little bit more. So it can also be more advanced. So R will allow you to plot, for instance, box plot. Now, why box plots are important in research, I will come back to that topic later on. But for now, what I want you to understand, how does this box plot work? For that reason, I have an example for you. And I need to show you a data set. So the data set for today's box plot representation, I'm going to use called empty cars. Now, why I'm using this particular data set? Because I'm from Germany and Germany specializes on cars. No, not that actually, because the thing is, well, it's a kind of a data set that you also have access to. For instance, if you install R, you have immediate access to this particular data set. So what kind of analysis that I'm running here in your system, in your computer, wherever you are, you can do the same analysis in your computer. That was only one of the motivation. So this empty cars data set, once you just type in, see, this is how the data set looks like. So you have the name of the cars here. You have the information on miles per gallon. You have the number of cylinders. You have displacement, horsepower, and all the other columns, all the other factors about all those cars. So what I'm going to do now, I'm going to use a library called ggplot2. It's the grammar of graphics. Now you need this if you're using R for the first time, you're supposed to install this by using the simple command called install.packages. Now, the good thing I think you might have already observed, if you just write inst, it automatically hints you towards this particular thing. For instance, it allows you to, if you just hit tab, it completes the command that you are supposed to type. Now, if you write install.packages, what you have to do again, just write ggplot, and then it again hints you towards this many available options. You just select this options and you can install it. But since I have been using this particular package a lot in my research results and in my research analysis, I don't need to install it again. But if you need that, you first install it, because otherwise, if you call the library, it will not appear and it will start complaining about it. So first you install it and then you call the library. Now, what does ggplot do? What are the modifications that we can make on ggplot? For that, I have to make a separate tutorial, because that itself is a topic, huge topic. So for today's tutorial and for today's a little bit of demonstration, I am not really going to give a dedicated session on that. I hope that helps. Let's run this particular code. So what does it do? We call the library ggplot2, and then how this ggplot actually works, you have to first mention the data set, that is empty cars. You have to maintain the aesthetics of what could be your x-axis, what could be your y-axis. Now, factor, cylinder, why did we write factor? Because these are the numbers and we want to plot them as individually. And the y-axis, we expect miles per gallon. So here, as you could see from the data set, cylinder information is here. That will be in your x-axis, and the miles per gallon information on the y-axis. Meaning that you would expect to see certain box based on the cylinders, like it will hover through your entire data set and find the cylinder numbers, and that numbers they will plot in the x-axis. So how many numbers are there, different numbers, and then they will categorize all based on the miles per gallon, all of the cars that they have in each box. And the title is miles per gallon by number of cylinders. So this is how you can also name it. You can also say something like, we are plotting miles per gallon based on the number of cylinders. It's the same. And as I said, it doesn't really matter, my friend, because the title can be something that you are writing on the top of your curve. And every time, I think you have noticed already, you do each modification, you are adding them with a plus symbol, meaning that on that layer, you are doing a modification. And then in the x-axis, number of cylinders. Now, if you want to make it a little bit different, you can also say something like this. And the miles per gallon is also simply mpg. Well, what I actually did now, I realized maybe it would have been better to just keep them like this, because now they are more abbreviative form, maybe not really that intuitive or easy to understand. Whatever it is, we will now plot this. Okay, yes, here we go. As you could see, so these are the NPG based on the number of cylinders. So we definitely had three different categories if you hover over this option. So we have certain 4 cylinders, 6 cylinders, and 8. So it categorizes them in 3 different categories in the x-axis, and the miles per gallons on the y-axis you have. And these are the different cars based on these 2 parameters. So it plots basically 2 different factors, and you have the box plots now. Well, needless to say, you can also change the color of the fill. Like this is light blue. You can also make it light green. By the way, all the colors that we are using here, You know that like you can also get a hex code for them, and it's always available in the internet. So what you can also do, if you are someone who uses unique colors in your plots, you have the access to the hex code. You get that hex code and you can actually type your hex code, just paste it over here, and then you would get the similar color that you expect to see. So light green, and maybe the color is black. So this is the border color of the box plot. See, now it changed. One last example I'm going to give you, maybe two, sorry. So the second last example will be on box plot, but here I would actually like to see the entries from the cars. Meaning that, as I said, in the y-axis, we have the miles per gallon information. So each box contains certain cars, but it is very difficult to follow them here because you can't see how many numbers of cars you have where you have 4 cylinders and you have this median values of miles per gallons, right? Well, as I said, I don't really want you to now focus on how box plot looks like and why is it better representation or visualization than any other plots. But I think just to give you 10 seconds crash course on box plot. So in a box plot, this particular dashed line is called median, and you also have first quartile, third quartile. These are called whiskers. And the best thing about the box plot is you can see the distribution of your data set, which you can't really see on a bar plot. And if it's median, it would also allow you to understand the central tendency, right? Over for now. Now, what we would do then again, we are going to do the box plot analysis for this thing, and we are now adding the car informations here. So at least how many cars are there? So how would you do that? You would call for a separate aesthetic features called geom jitter. So these are the jitter dots, and you would also then try to add them on the top of your box plots. And then once you run this code, so this many cars you have, again, you can play around with the size of those dots. You can make it a little bit bigger, for example, 6. And the alpha is the transparency of those dots. If you make them to be very strong, you can make it like alpha equals to 1. Now, if you just do that, just rerun your code. So these are the dots. It looks very bad, of course. But yeah, you can also decrease the size maybe a little bit. For instance, 2. And then alpha is also not that great, actually. The one it was previously was better, actually. Well, see? So these are the car informations you now incorporated. Now you have actually already introduced 3 different things. One is miles per gallon information on the y-axis. You have the number of cylinders in the x-axis, and these are the representative, meaning that in this box plot, you have the information on all these cars. This same, and this is for the 8 cylinders cars. Now, what if I say you make it a little bit more complex and try to now really have the information on what are those cars? So you have now 3 different variables that you are considering. Is it possible? Why not? If you introduce a third filter on something called as color variable, if you can color them and if you have a legend on those particular colors, you can easily do that, right? Can't you? For that, what you have to do now, you again use the same data set. Empty cars, aesthetics are all good. But a small things, what I did here is I just colored all the row names of the empty cars. What does it say? Row names, as you could see, these are the row names. 1, 2, 3, we have this many rows, and this row has their unique names, of course, because they are different cars. And I want this particular program to plot all those row names and color them accordingly. Now, if you could do that, I think that can be the most beautiful representation you can have. What it does actually. So it's basically the box plots again, Based on the number of cylinders, it plotted the miles per gallon in the y-axis. And by the way, you can also increase or try to readjust your plot. Of course, you can export it as SVG PDF. You can, like for image, if you go and just image format, you can also follow all these options, right? So I will come back to all this later on because my today's intention, although the video duration is getting longer, I would now quickly just tell you a few more things and then I'm done with my today's presentation, for instance, because like it doesn't really make sense if I make it unnecessarily long for you, right? So these are the box plots as you have. Now this unique colors also represents the company that we have. It's very difficult to follow because some of the colors are very close to each other. You can also have different color palettes. For that, you can also use some resources from online. But up until this point, I hope you were convinced that R has the capacity to produce such a unique and good-looking plots, what you can't really do necessarily on any third-party tools. Well, with that being said, I also want to emphasize on I'm not promoting R because I don't have to promote it. It's already so popular amongst the researchers and people are using it for their day-to-day life. At the same time, it's also important to remember all people really like that everyone doesn't have the capacity to do the coding and they feel it as a biologist. It's my personal opinion. Also, it doesn't really apply to you, but as a biologist, I feel like we remain or we tend to stay a little bit skeptical about all this computational part, and that's totally fine. Of course, like before I moved to Germany, I never did this in my life. In India, like of course, I didn't have access to all this. And I didn't really learn all this. In Germany, once I started my PhD, I understood the necessity of it, and then I'm using it my day-to-day life. So yes, with that being said, I'm at the end of my today's presentation almost. So like any other scientific literature or scientific tools, you must acknowledge the hard work that people are doing. So the developers. So how can you cite R if you just write citation, parenthesis, open parenthesis, close parenthesis. So this is you have, and you can actually use this information for your referencing purpose for the paper that you have been writing, where you used R as a tool to analyze your data set. It's also important to mention that if you use certain packages, you need to cite them as well, because for that also, there are a lot of developers. They have been working so hard to deliver you something, such a beautiful visualization like this, right? So for that reason, you can also specify your package and just say citation. And it's like this. You can also use the bib text entry if you are using LaTeX, and then you can also use those information for the citation purpose. With that, I'm almost at the end of my tutorial, and I thank you one and all for actually for joining today. And I really appreciate your patience, and I hope that I can cover some of the essentials in my upcoming lectures. And I hope you enjoyed too. And also, if you have any questions, don't forget to type them in the comment box. I will answer them, rather try to answer them in my free time. Thank you so much. See you in the next video. Bye bye.